Let's talk about the converse to the Pythagorean theorem. In the previous video, we learned that if it's a right triangle, then the sum of the squares of the legs of that right triangle is equal to the square of the hypotenuse. In other words, a squared plus b squared equals c squared. The converse of the Pythagorean theorem switches that around. It says that if you can show that a squared plus b squared equals c squared, then you will have proven that that must be a right triangle. So we're starting from a position of not knowing whether it's a right triangle or not. We know all three side lengths, but we don't know whether it's a right triangle, acute triangle, or a obtuse triangle. If you can show that a squared plus b squared equals c squared, then it must be right. But if a squared plus b squared is greater than c squared, then it's an acute triangle. Now c we typically think of as being the hypotenuse, but in this situation, since we don't know whether it's a right triangle or not, we can't actually call it the hypotenuse. C instead at this point would just be the longest side, and A and B are the shortest side and the middle side. So if the sum of the squares of the two smaller sides is greater than the square of the longest side, then it's an acute triangle. And if it's less than, if A squared plus B squared is less than C squared, then it must be an obtuse triangle. So let's take a look at a few examples. Our goal is to determine whether this is a right triangle, an acute triangle, or an obtuse triangle. To do that, we need to identify which sides are A and B and C. We don't have a hypotenuse in this situation because we don't know if this is a right triangle or not. Instead, C is just the longest side, which is 41 yards for this diagram. So 9 and 40 are A and B, and 41 is C. So I'll write this equation, 9 squared plus 40 squared. And I don't really want to write an equal sign or a less than or a greater than here yet because I don't know what the answer is. I don't know what symbol I should put there. So for now, I'll just put a question mark. And then I'll start simplifying. That's 81 plus 1600 and 1681. So we actually end up with 1681 on both sides. So instead of a question mark, I could replace that with an equal sign. So since I have shown that a squared plus b squared equals c squared, I have shown that this triangle is a right triangle. Let's look at another one. It might look scary because we have fractions, but luckily all of these fractions have the same denominators, so when we're identifying which side must be c, which side is the longest side, you can just find the side that has the biggest numerator. So 9 halves and 15 halves would have to be a and b, and 17 halves, because it's the biggest, would have to be c. So I'll write this equation, again leaving a question mark instead of an equal sign, or a less than or a greater than, because we don't know what goes there yet. I've got 9 halves squared plus 15 halves squared and 17 halves squared. You can do this in a calculator, or really you could probably do this in your head, because if you're squaring a fraction, it's the same thing as squaring the numerator and squaring the denominator. So I would have 9 squared over 2 squared, in other words 81 over 4. And then same thing here with 15 squared over 2 squared, that's 225 over 4, and 289 over 4. So again, I end up with all of the same denominators, which means combining like terms here is pretty simple. I get 306 over 4 and 289 over 4. So since they have the same denominator, comparing their numerators is really all I have to do, and 306 is obviously bigger than 289. So what I have shown here is that a squared plus b squared is greater than c squared, which means this must be an acute triangle. Our next problem, again, might feel a little intimidating because we have a radical instead of nice pretty integers, but it really works the same way. Figure out which side is the longest, that's c, and then the other two must be a and b. So really you need to figure out a decimal approximation of 8 times the square root of 3. So just type that into a calculator real quick, and it'll give you a decimal approximation of about 13.856. 13 is between 7 and 16, so that means that 16 must be c. c is the longest side, 16 is the longest side, so that means that 8 root 3 and 7 are a and b. So let's write our equation and simplify. 7 squared, of course, is 49. And then 8 times the square root of 3 squared. Either type that in the calculator or think about what you're actually doing here. If you square 8, you get 64, and if you square the square root of 3, you just get 3, right? The square root and the square cancel out, so really you're multiplying 64 times 3, and that's how I got 192. If your radical skills are a little rusty from last year, just type it in a calculator. Simplifying, I get 241 on the left and 256 on the right, so that means that it's a less than. A squared plus b squared is less than c squared. So that means that this must be an obtuse triangle. I want you to pause the video and try this last one on your own. All right, let's see how you did. The first thing you need to do is identify which side is c. C is the longest side, and in this case that's 30. So 24 and 18 are a and b, 30 is c. So I've got 24 squared plus 18 squared. That gives me a total of 900, and also 30 squared is 900. This ended up being equal. A squared plus b squared equaled c squared. So this must be a right triangle. And that's all you need to know about the converse of the Pythagorean theorem. In the next part of this lesson, we're going to learn how to apply the Pythagorean theorem to solve real-world problems.